Hello, this is Mrs. Ward, and I'm going to go over the 5.3 classwork worksheet, and so we're going to start. So the first one says find all the solutions, so this means we're going to have multiple laps around our unit circle, and I'll show you how to handle that at the end. So this one, I have two things that are multiplied by each other that are set equal to 0. So I'm going to use the zero product property and set each one of those equal to 0 by itself. So I'm going to have 3 tangent squared x minus 1 is equal to 0, and tangent squared x minus 3 is equal to 0. Here I'm going to add 1 to both sides, so I'm going to have 3 tangent squared x is equal to 1. Divide both sides by 3, and tangent squared x is equal to 1/3. Now I'm going to take the square root, and when I take the square root of the numerator, take the square root of the denominator, so you're going to have tangent of x. Square root of 1 is 1. Square root of 3 is the square root of 3. Since I took the square root, I was either going to be positive or negative, so I'm going to write plus or minus. And if I wanted to rationalize, this would end up being plus or minus the square root of 3 over 3. So then I'm asking myself, when is a tangent equal to plus or minus the square root of 3 over 3? And that ends up being at pi over 6. And 7 pi over 6, that's when it's equal to a positive square root of 3 over 3, and it's equal to a negative square root of 3 over 3 at 5 pi over 6 and 11 pi over 6. And I like to just go in order of the unit circle, so I'm just going to go around first quadrant, second quadrant, and so on. Since it says find all solutions, I'm going to add multiples of 2 pi at the end. In your book, you may only see pi over 6 and 5 pi over 6 listed, and then just adding one multiple pi, and that's fine, because if I add 1 pi to 7 pi over 6, it'll give me the 7 pi over 6. And if I add 1 pi to the 5 pi over 6, it'll give me the 11 pi over 6. But I like just to be consistent and do every single problem the same, so I'm just going to write the 2n pi and list all the ones on one lap around the unit circle. So the next one has tangent squared x is equal to negative 3. So I'm going to add 3 to both sides. So the tangent of x is equal to 3. Taking the square root of both sides, square root, I'm going to get the tangent of x is equal to plus or minus the square root of 3. And that's going to happen when my denominators are 3. So that's going to be pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. And that's just going around my unit circle, and then I'm going to add 2n pi to show that I have a lap around the unit circle. And give me a second so I can get that next one down. So I just brought the other one to another page so I had more room to work on it. So this is something that needs to be factored. If I had x squared plus 2x minus 3 is set equal to 0, you would factor it by saying x, 3, 1, plus, minus, and that's the way you would factor it. Or some of you learn to do the x squared plus 3x minus 3, and then you separate by factoring out x squared, factor out negative 1. You're still going to get the same thing. So however you factor, that's how you're going to factor. So when I factor this, this is going to factor as cosine x minus 1 times cosine x plus 3 is equal to 0. Using the zero product property, I'm going to set each parenthesis equal to 0 and then solve each one independently. So here I'm going to add 1 to both sides, so the cosine of x is equal to 1. When is the cosine equal to 1? That happens at 0 and 2 pi. And since it wants all solutions, I'm going to add plus 2n pi, which again, I could have just written 0 plus 2n pi because that would have covered that 2 pi. Here I'm going to subtract 3 from both sides. And I'm asking myself, when is the cosine equal to negative 3? Well, the cosine fluctuates between a negative 1 and a positive 1, so this is not possible. So since it's not possible, I do not have any solutions from this side of the equation. I do have solutions to the equation. They are this. I just don't happen to get any solutions from this side of the equation. Next one, number 3. Cosecant to the 4th is equal to 4 cosecant squared x. Again, you cannot divide by anything that might be a 0. So I'm going to have to bring this 4 cosecant squared over to the other side. So 4 cosecant 4th minus 4 cosecant squared x is equal to 0. Here I can factor out a cosecant squared. And I'm going to have cosecant squared x minus 4 is equal to 0. So then I'm going to ask myself cosecant squared x, zero product property, set both of them equal to 0. Here, I'm going to take the square root to both sides. Well, the square root of 0 is 0. No need to write plus or minus because it's 0. So the cosecant of x is equal to 0. So let's think about this. The cosecant, this is understood to be 0 over 1. The cosecant is a reciprocal of sine, so sine is equal to be the reciprocal of this, which is 1 over 0, and that's undefined. So here I'm not going to have any solutions from this side. And be careful to say that there's no solutions from this side. There may be solutions from this side, so I'm going to work on this side now. Cosecant squared x is equal to 4. I added 4 to both sides, taking the square root of both sides. When I do that, I say cosecant squared, oh no, I took the square root, my bad. Cosecant x is equal to plus or minus 2. So 2. So that's the cosecant. So I'm going to go the sine because I know sine better. This is 2 over 1. So I want to know when the sine is equal to plus or minus 1/2. Well, that's easy. That's when this anything with a denominator of 6. So I'm going to write everything with a denominator of 6, one lap around my unit circle. And since it wanted all solutions, it did, I'm going to write plus 2n pi. Okay, doing number 4, I have 2 sine x is equal to 1. I'm going to add 1 to both sides. So I'm going to have 2 sine x is equal to positive 1. Divide both sides by 2 and get sine is equal to 1/2. I did not take the square root, so I'm not going to write plus or minus because it's just going to be the positive 1/2, which one lap around the unit circle means I'm only going to get 2 answers, and that's going to be pi over 6 and 5 pi over 6. I'm not going to include the negative ones because they don't work. And then I'm going to write plus 2n pi. Okay, number 5, again, can't divide anything by what might be 0. Paying attention to the directions, I'm just doing one lap around the unit circle, and that is it. I'm not adding any multiples of pi, 2n pi at the end. So here I'm going to subtract cosine x from both sides. I know it looks like you could divide both sides by cosine, but if you do that, you're losing a 0, and you don't want to lose your zeros. So here I'm going to factor out a cosine x, and I'm going to have cosine squared x minus 1 is equal to 0. Using the 0 product property, I'm going to set the cosine x equal to 0, cosine squared x minus 1 equal to 0. When is the cosine equal to 0? Well, that happens at pi over 2 and 3 pi over 2. This, I'm going to add 1 to both sides, take the square root, so square root, cosine x is equal to plus or minus 1. Well, that happens at 0 and 2 pi, and then it's equal to negative 1 at pi. So those are 0, pi, 2 pi. So these are all my solutions. And again, not adding multiples of pi because I just want one lap around the unit circle. Number 6 is kind of a tricky one because I notice I have 2 different trig functions. Well, that's not going to work. I can't factor with 2 different trig functions. But I do have a way of rewriting sine squared in terms of cosine squared. So I'm going to rewrite sine squared as 1 minus cosine squared using the Pythagorean identity. And then I'm copying down everything else. I'm going to distribute my 2. And I'm going to put it in descending order while I'm at it, if you don't mind. So I'm going to have negative 2 cosine squared x plus 2 plus 3 cosine x minus 3 is equal to 0. So negative 2 cosine squared x, then plus 3 cosine x. And then when I add the 2 plus the 1, negative 3, I get negative 1 is equal to 0. Okay, so I have a phobia after 30 years of doing this. I hate my lead coefficient being negative. I just hate it. So what I'm going to do is basically I'm adding everything over to the other side. So I'm going to put my 0 here and have 2 cosine squared x minus 3 cosine x plus 1. So you can either think of it multiplying everything by negative 1 or taking everything over to the right side. I just like my lead coefficient to be positive. So then if you're not a big, huge fan of factoring, you're going to work this off to the side. But this will end up factoring as 2 cosine x. Then here will be a cosine x. The only way I can get 1 is 1 and 1. That's a 0 there. And then since I wanted this is going to be minus 1, that'll be minus cosine x minus 2 cosine x, which can be 3. Okay, that works. Oh, I have my minus 0 over here, so I don't have to write that. My bad. So now using the zero product property, I'm going to have 0 is equal to 2 cosine x minus 1, and 0 is equal to cosine x minus 1. Here, I think this is the same work as up here, is it not? Yeah, cosine x minus 1 is equal to 0. All right, I'll do it. 1, 2 cosine x, 1/2. Oh, my bad. I was wrong. It's not. So cosine of x is equal to 1/2. That happens at pi over 3. And the next time it's positive is 5 pi over 3. Remember, I'm only doing positive because I didn't have to take the square root. It's not plus or minus. Here I subtract 1 or add 1. I get 1 is equal to cosine of x. So when is the cosine of x equal to positive 1? And that happens at positive 2. So these are my answers, just those 3. So this one, everything's in the same trig function, so I'm just going to factor. So 2 cosine x, 1 cosine x, 1 equal to 0. I want a negative 3, so these are both going to be minus again. Oh. So now this will end up set both of them equal to 0. So this will be 2 cosine x is equal to positive 1. Divide both sides by 2, 1/2. And that ends up being pi over 3 and 5 pi over 3. Add 1 cosine x is equal to positive 1. That happens at 0 and 2 pi. And those are going to be my solutions for that one. And then the last one is cosecant. So I'm going to add 2 to both sides. The square root of 3 cosecant x is equal to 2. Divide both sides by the square root of 3, and the cosecant of x is equal to 2 over the square root of 3, and it's positive. Not familiar with cosecant from my unit circle, so I'm going to take the reciprocal, which is sine. So it's cosecant is equal to 1 over sine. So when I find the sine of x, I'm just going to do the reciprocal of this, which is the positive square root of 3 over 2. Again, it's just the positive square root of 3 over 2. And that happens at pi over 3 and 2 pi over 3. And those are my only 2 answers because it wanted in one lap around the unit circle. So that finishes the classwork. I hope that helps, and we will see you next time.